Propositional theorem proving in AI involves using logical reasoning to demonstrate the validity of a proposition. One method is resolution, where contradictory clauses are resolved to derive new clauses until a contradiction is found or all possibilities are exhausted, proving the proposition true or false. AI systems employ algorithms like resolution refutation to automate this process efficiently. Sure, let's consider the problem of proving the validity of the propositional formula. PQR, left and right arrow, PQR. We want to show that this formula is a tautology, meaning it is true for all possible truth assignments to the variables P, Q, and R. We can use propositional theorem proving techniques to demonstrate this. One approach is to transform the formula into an equivalent form using logical equivalences and then apply resolution-based theorem proving to show that the resulting formula is always true. To demonstrate that the propositional formula, PQR, left and right arrow, PQR, is a tautology, we can proceed as follows. 1. Transform the formula, apply logical equivalences to rewrite the formula into an equivalent form. 2. Apply theorem proving, use resolution-based theorem proving to show that the transformed formula is always true. Let's start by transforming the formula using logical equivalences. PQR, left and right arrow, PQR. Apply the definition of implication. Tilde, PQR, left and right arrow, tilde P, tilde QR. Apply the definition of implication again. Tilde, tilde, PQR, tilde P, tilde QR, tilde, tilde P, tilde QR, PQR. Apply De Morgan's laws and distribution. PQ, tilde R, tilde P tilde QR, P tilde Q tilde R. Apply distribution again. PQ tilde R, tilde P tilde Q tilde R, tilde P tilde QR. Apply distribution again. PQ tilde R, tilde P tilde Q tilde R, tilde P tilde QR. Apply commutativity and associativity. PQ tilde R, tilde P tilde Q tilde R, tilde P tilde QR. Now, we have a disjunction of three conjunctions. To show that this formula is always true, we need to demonstrate that at least one of these conjunctions is always true for any truth assignment to P, Q, and R. 1. If P, Q, and R are all true, the first conjunction, PQ tilde R, is false, but the second and third conjunctions are true, resulting in the entire disjunction being true. 2. If at least one of P, Q, and R is false, then the second or third conjunction will be true, making the entire disjunction true. 3. If P, Q, and R are all false, then the second and third conjunctions will both be true, again making the entire disjunction true. Therefore, we have shown that the formula PQR, left and right arrow, PQR, is a tautology, meaning it is true for all possible truth assignments to P, Q, and R.